Yes, you to the cloud.
So now what we need to do is to download the workshop materials for this workshop. So you go back to the link I sent on Friday and you go to the workshop materials. And there we're gonna find two folders, part 1 and part 2. Part 1 is gonna be representing the material that we're gonna be using for day 1 and day 2. And it's basically the, like very solid foundation. And part 2, once we have learned all the different tools, it's going to be much more simple. So keep in mind that that the last day is going to be the more relaxing day. So stay with me until the last day, because I think that it's going to be important for you to accomplish and complete this course. So then we go to part 1. And there now, let me just leave it here. There now, what you could do is to press that specific bottom, and then you can say download. And then you can say, it's gonna download to my download folder. Let me just leave it here. Yeah, oh, never mind. And so normally in Mac, you can just press twice in order to unzip the file. I know that in Windows it's different. I know that Linux is different. I'm gonna put that folder, let me just, that specific zip file into my PM, which is my desktop. And then I'm gonna press twice because I have a Mac, and that is gonna uncompress the zip file. So give me some reaction, maybe, let's see, just say like, give me a yes if you have downloaded the folder and in our chat. So yes, oops, to everyone. Yes. Okay, I can't count, but I guess we have received plenty of yeses. Okay, great. And then because you have already installed R and RStudio, the only thing that you need to do is now to go to that part 1 R project and press into the open with. I think it's going to be default RStudio. My computer is slow. Yeah, so then you say, I want to open this part, the .r project file with RStudio. So tell me if you have managed to open the R project file within RStudio. So I'm gonna say like 1, and then the next person do 2, 3, 4, 5, so we can count. Great. Can I do that? How do I do that? How do you do how do I count? Does anybody know?
I think you have to turn off the share screen, maybe.
Then you can go to participants and then you'll see hands beside our names.
Okay, and then, but you guys need to keep that. Yeah.
Yeah, the hand will stay up permanently until you put it down.
Okay, I see. Great. I'm not as an expert on Zoom as you guys are, and I'm so sorry for this. So 22. I'm gonna wait. So 22, yeah, I'm gonna wait a little bit, like 3 more minutes on this. Does anybody have any question about our installation or our studio installation? Do you guys, like for those, do you have any questions or?
I have a question. So when I installed it, it just opened it directly in our studio. It didn't take me to like the desktop screen that you were showing when you had to like do it as a zip file. Is that, do you know why that's different?
So you just, go ahead, say again, you just.
Yeah, so I went to the shared folder and then when I downloaded the rproj file, it just opened it, like it downloaded it directly to our studio. I didn't have to do anything on like my desktop that you were showing.
But did you download just the entire file folder or you download just the .r project? Because
Just the R project.
so that is not a good thing to do because we are gonna need everything. So basically you need to go, sorry, I need to share this again. Basically you need to go on top, like on the top corner where it's written part 1 and download the entire folder and not only the R project. Let me know if you get it.
Okay, thank you.
How many of you, how many of you are using a Mac or a Windows machine, a PC or a Linux? I don't think many use Linux, do you? Yeah. And Windows. Okay, so mostly Mac or some Windows. And the people that are interested in working with single cell, are you guys mostly grad students? Postdocs. Grad student. Okay. Postdoc. Cool. Okay, we have plenty of postdocs here. Okay, so I think like let me know. I'm gonna move forward because we just want to get things started. But if you have any specific questions, don't hesitate to ask Si-Yoon. I think he can troubleshoot your problems, you know. So I'm just gonna keep going forward. But if you were unable to install our studio or had other problems, just ask Si-Yoon, and I'm just gonna keep going forward with our exercise. So can you all see my art studio file? Like here? Yeah, you can see, they can see my screen. So basically this is the R Studio interface. So it's an interface that we're going to be using to run R. And the cool thing about these interfaces that has different panels here that are these different boxes here that are going to be useful once we start dealing with the data. So like I said before, when we open that R project file with our student, it also opens other things that are within that file. As I don't know if you remember, but within that file, when we unpacked or uncompressed that, we could see that there were 2 different data frames or CSV files. We could also see that there is a file here named part1.r, which is a R file. And we could also see that there was a part1R project. So to get started, one thing that we would be doing is to first of all click in this part1.r. And this is basically the file that we would be writing our scripts in. And that is the file that we're going to be running our scripts from. So just to get started, R is one of the most commonly used and powerful statistical programming languages and used to analyze and manipulate data for virtually every professional industry. And basically here, I think that most of you guys are doing biological analysis, right? But it could be used in the statistics field or medical field or beyond, so political field. So over the last 10 years, powerful new tools within R have emerged to make data manipulation and visualization even easier and more accessible. So the powerful thing about R is that it's an open source program. And for that reason, many people can contribute by creating new projects and introducing these new projects to the R library. So R is open source, which means that it will remain freely available to those who need to use, but also may change its capabilities and improve over time. So how does R work? So basically we have R as the program can read our data. Our data could be this, like we had here, the CSV files, right, that we talked about. And it takes that data and it stores that temporarily in the memory. So when we have this data here, it's an object that is stored temporarily in memory. So when we do some edits, when we do some data manipulation in that specific object, we are only editing an image of it. And the original data file stays intact and unaffected. So you can then create and modify your data sets as much as you want within the R environment, within R Studio. And then if you are happy enough with your modifications, then later on you can overwrite your original file, or you can create a new data set .csv with your data manipulated, you know. So this is called like non-destructive editing, because you're not really destroying your original data. You're just taking a copy of that and modifying it and saving it in another file as another file name if you want. And the other thing that is powerful about R is that it can create new objects out of your data frames, and as opposed to just reading from a file. So R basically can do everything you'd imagine, and by using R scripts, which are the files with .r, which has the .r in the end of their name, you can keep a record of everything you have done to manipulate and analyze your data. And this is going to be beneficial later, right? Because, for instance, if you're doing this for your research, right, you'd want to, first of all, if you're publishing the analysis in a specific journal, of course, you want that to be reproducible. So instead of only giving the data to the people that are for that specific journal, you can also give the data and the scripts that you have used for manipulating and for producing the research you just did. So it can be very powerful as a reproducible tool, and also to make sure that you are organized on your way of thinking, right? Like you can really document what the many steps you have done to achieve or to accomplish specific results. Does anybody have any questions so far? I can have a look at the chat. So Ralph says that he has I have package tidyr required but not installed message. Is that required here? Yeah, we are gonna very shortly figure out how to install a package. And yeah, so just wait for a second. So this course was designed by Ibrahim, another Kisio Bio collaboratory researcher, for beginners, you know, who have little to no experience with R programming, or even like with programming at all. So if you guys want to learn, this is the place to be. And over this course of this 3-day workshop, we will cover the topics described below. So first day, we are going to be doing like an introduction to our studio, how to find help when we need help, how our studio cheat sheets, how to install packages, as Ralph just asked, how to load in libraries, and we are going to understand what are the names of the data structures that are present in R, and the classes, the different classes that are classified in R. And you guys are gonna, if you guys are not familiar with this type of language, like programming language, I'm sure it's gonna be a lot of information to be learning, but don't be afraid, don't feel overwhelmed. This is a process. This is like learning a new language, and we are all here to help and to help each other. And we are also going to be learning how to import data, like how can I import this specific data that I find in that folder that we just downloaded and unzipped. And most important, how to examine, like to analyze the data sets that we have imported. And then in day 2, we are going to learn how to do some very simple data brokering, data manipulation, which is like how to filter data sets, how to select, and how to calculate specific columns with tidyr and divider. And we are also going to learn about the power of R as a data visualization. So we are going to learn how to produce plots with this package called ggplot or library ggplot. And sorry, ggplot2, not ggplot. Ggplot is the function. And in the day 3, like I said, these 2 first days going to be like very slow. But then in the day 3, we are basically going to apply all the information that we have learned in day 1 and 2. And we are going to learn about R Markdown basics. Basically, what R Markdown does is to compile in a document. It could be a HTML document or a PDF file or a Word document, compile everything that you have written to that document. And this is very, very useful as well, because, for instance, if you wanna, you're doing some analysis and you wanna share that with your PI. So instead of just sharing the plot, you can also just like type down your conclusions with the plot, and makes it very, very clean and very tidy, like very nice to just like send a report to your PI instead of just sending the plot, you know. So throughout the course, I'm going to be talking as you may notice. And if you want to like yourself take notes for a specific reason, I think that this what she said or is important, then the way you do that in R is to use the symbol hashtag. So you can see here, if I say blah, this is gonna give me an error, like, so it's saying like unexpected token blah. But if I say here, if I use the hashtag, then this becomes a comment that I can type. So just you guys maybe like type for a second, or and our student can even help in the misspelling. Just type for 2 seconds a comment, just so you guys remember this. That hashtag is used for writing comments in your .r file. And then if you want to save, you can just use in Mac Command S as a shortcut, or how is that in Windows? I don't know. Control S in Windows. Thank you. So yes. So just briefing for a second. You guys have written your comment with the hashtag. So basically now, the first thing that we are going to learn about is about the layout of the RStudio. Like I said, RStudio is just a tool to be able for us to be able to run R. R is what we have here. You know, my R version is 4.03, and here they say the copyright and R is free, so it's a free software and comes with absolute no guarantee. So whatever we do here, it's our responsibility. So this is what R is. RStudio is the platform that we are using to run R. So, like I said, we are going to be moving very slowly in the beginning of this workshop, just so we understand what the different things are. So once RStudio is open, the first thing that one should take a look around is the user interface. So everything that is around here is the user interface. The left side is the terminal. Once you open our source file, so the left side is the terminal. This is the terminal, the console, also known as console. Once you open our source file, codes and scripts are displayed in the top left hand corner. So this is what we call code or script. And then the bottom left remains as the terminal where code can be typed or copied. So basically what we are going to be doing is to, like later, is to, when we have a specific code, we are going to transfer this code from the specific R script file to the terminal. And then the terminal is going to process our code. The top right is the global environment, which is where information about objects and variables is stored. For now, you don't need to understand what it is, what objects and variables are, but whenever you do you remember, like when I was talking about data frames that were stored in memory as a copy of your object and not necessarily like your original object. So the way that they do it, they store in this global environment. So everything that we are going to be producing, let's say we compile a data frame and then we modify the data frame, that is going to be showing up here. For now, you don't need to worry too much about, but later in this workshop, you're going to understand what I'm talking about. And then the bottom right panel is the most important panel, because So because it has plenty of functions, so it has the files. So all the files that were in that part one folder are shown here. So here basically we know the size of the file, and it gives some more when it was modified. So it was modified 25th of January. And then here, whenever we produce a plot, the plots are going to be shown in this panel. And then here are the packages that we are going to be using or installing in order to modify our data. So there are, like I said, there are a bunch of different free packages out there, and the way that you find about one package, like ggplot, I was talking about ggplot too. So this is the main package that we're going to be using to plot stuff. And then if you want to install, you can just press install there, but we're going to be learning later. And then, for instance, if you don't understand about a specific function or about a specific plot, then you can just say, I don't know what ggplot is. So you can use the tab help in order to figure out about a specific package or a specific function. And then the view tab is for viewing local web content or web-based graphics, but it's not, we are not going to be using it much. So another thing that is very important that we're going to be doing now is that there are some global options that you may want to review before beginning our workshop, which is allowing the soft wrap, because this soft wrap is going to make it much easier for you to view the code in the top left window. So this code here. So I wanted you guys to change the settings with me. So we go to tools. Oops. We go to tools, and then there, oops, we are going to go to the global options on the last, as the last argument of that window. And then we are going to go to code, and then we would want to press to take the soft wrap our source files as yes, and then we would want to apply that. And you just say, okay. And if you go back there, you're gonna see that in code, we have that applied. I wanna see if, have you done the soft wrap? Oops, wrap. You got, maybe it is normal, maybe just try. I think it, Emma asked, it made me restart our studio. Is that normal? I think it is normal. Just go and check if you got that global options modifier there. If they're in code, you have that like fixed after it restarted. Another thing that is very useful, and that you guys can like kind of personalize your RStudio is by doing this, going to RStudio here and doing preference. And then here you're gonna have a bunch of different things, but one of the things that is kind of like nice is to deal with appearance. So some people, I prefer, this is my own taste, I prefer the theme to be white, so with a white background, but some people would prefer the black background. If you do so because it makes your eyes, it's appealing to your eyes or whatever, you can change here, then you could just do apply. And it's fun, right? You feel more like a coder if you have a black background. I don't know, but do your way later or now. You can play around with that. Okay. So like I said, we have R as our program, and then our studio as our platform to run R. And then we have different panels that are going to be helping us visualizing what is going on with our manipulations of the data sets, right? But for R to be useful, like I said in the beginning, we need to install different packages, right? Because different packages are going to do specific things to our data set. So for that reason, we need to be able to install a specific package in order to be able to manipulate our data. And in the way that we do that is by using this function called install package. And the package that we're going to be using throughout the course of this workshop are the following packages described. And what you basically do, and I want you guys to type with me. I know that is already written there, but I want you guys to type with me at the same, just so you reinforce in your memory how to do this. So you can, this is a function called install packages. It's a function that is already written with an R, so we don't need to install the function install packages to install packages. And what is powerful about R Markdown is also that our students, that it gives you how do you say, some possibilities, right? Once you started like typing the name, one thing you could do is to just click there. Yes, I want the function install package, and then now you say that you want the packages type R to be installed. And for you to successfully install, you need to write the name of the package in quotes. So you press the quotes button, and then you write tidy R. And then this is the power of R, that from R to the terminal. One thing you could do is like copy and paste. And like I said in the beginning, you remember that I said that this place is the terminal. And then you could, that would also start the code that will do something with the code that you just wrote. And then you could press enter. Or instead of copy and paste it all the time, what is very interesting about our studio is that you could use the like shortcut command enter, and that would go, or control enter in Windows, or control enter in Linux, that would like automatically paste this specific function to the terminal. So please try now to install all these different packages with this shortcut. So I'm gonna say shortcut for copy and paste of the .r to the console is to type command plus enter Mac, or control plus enter Windows Linux. Okay, so we are going to be installing all these different packages. So I already did that. So command enter dplyr. Yes. So I'm gonna give you like 5 minutes for you guys to install everything. And let me know once you have finished the installation. Did you, Kanika said, and what is it given to you? So Kanika said, I tried installing tidyr, but nothing seemed to happen in the RStudio interface.
Yeah, I mean,
So-
on your window, it showed downloaded 1.2 MB, right? I did not see any message or any other thing flashing on the screen.
And are you doing Command or Control Enter?
I just copy pasted and pressed enter.
And
Windows.
when you have this console here, do you have this specific thing showing up?
Yes. Yes.
And are you sure you're writing it correctly?
Yeah, there are no typos.
Interesting.
And you don't see anything red?
No, I mean, I just see the command that I copy pasted to the console and nothing happened after that. I just moved to the next line.
Can you just do the Control Enter instead of copy and pasting?
Okay. It still did not happen. I'm also not getting that greater than sign in the console that you get when you are, it's like a command prompt. When I'm not getting that.
That
This
means,
one.
Yes.
yeah, that means the R is hanging, basically, I think.
Okay. Should I
And you
restart
install-
it?
Yeah.
Maybe restarting might help.
Did you install R and RStudio?
Yes.
And yours is a Mac or Windows?
Windows. Okay, I'll try restarting and then update what happens.
Okay, perfect, thank you. So I don't think it's gonna take 16 minutes, Daniel, but we never know, you know? So as you can see here in so we always gonna get some information from R, you know? Some are meaningful and some are not. But so here it goes to a specific mirror and it tries to download specific gunzip file, right? And that is going to have the content necessary to install this specific package called Lubridate. And then it said that downloaded and the size was 1.4 megabases, and the place that it was like this binary package was downloaded at is in this specific directory. So it was downloaded to that specific directory. Oh, nice, Kanika. I don't know what happened, but yeah, sometimes it's good to reset. So tell me if you have installed everything. Oh, another thing that you can see, another way that you could install this is by saying, like here, tidyr, and then press here, tick that specific box, and what it, oh, sorry, no, this is to load the package. But one way to check whether or not you have properly installed your packages to search, because here's all the packages that you have already installed. And then here you could search dplyr, if you write it correctly, dplyr. So now it's installed there. T-bone, it's also installed, and so on, you know. So yeah, you can ask. I don't know how to pronounce your name. Can you help me?
Yeah, no problem. It's Abdurrahman. Just what's the tick for?
You're gonna learn that it's to load the package. Like once we install a package, it's not enough to tell R that we want to use that package. You also need to load the package.
Okay.
And that is what we're going to learn in a second. So yeah, like I said here, command or control plus enter or return. I think enter is a Brazilian way to say that. Yeah. So like I said, the TidyR dplyr and table packages are built to organize and clean data that we're going to working with. The package ggplot, rcolor brewer are used for data visualization and color blending. So data visualization is our ggplot and color blending is our color brewer. The loop date package is used for working with dates and times when plotting. And with all of these we're going to be using later during this course of this workshop. So once we install, like I said, once we install the package, we can see them listed here. And then in order to use the installed package, we actually need to use to load the package into our R session. And to do this, we can use the function called library. As an example, now here we are loading the package TidyR using the function library TidyR. So, and then like I did before, command enter, and now I loaded the package TidyR to this R session that we are using right now. So to be useful, in order to use all these different packages that we loaded, we now need to load them to the R session. And what I'm going to be doing here, and you guys should do as well, is to modify this. Instead of installing now, we're going to be typing library to actually not only typing, but also run that code to load the package to the R session. Do you guys have any questions in terms of what a function is, what a package is? So now, as you can see here, I'm loading all the package that we just installed to our R session. And if you are careful enough, if you are detailed enough, you're going to see, like, for instance, lubricate now is stick there, right? Because one way to do that as well, if you like just clicking, is by doing TidyR like we did before. Now the attached, but then we want to attach it again. Basically, we do what we just did in the command line. We do that by just clicking in that box, on that box. Okay, so I want to ask, have you loaded all installed packages? And then you should say yeah, or one. Okay, I start with one. Or maybe we yeah, you can raise. So Ricardo Fausto raised his hand. Do you want to ask, or you just raised the hand because you have done that?
Just because I did it.
Okay, cool. The problem about raising the hands is that, isn't that then I need to stop sharing in order to count? Is that true?
You don't have to. You can just look at participations tab.
Okay, so raise your hand then. Perfect, awesome.
Hi, I have a question.
Yeah,
So, how do I know that I successfully loaded the package?
like I said before, like if you go here in the panel, oops, if you go here in the panel package, and then, for instance, I haven't loaded this specific package A, but if I do so, if all the packages that I have loaded are ticket like with like a specific, so you can see that we have some default package like base R here that were already loaded once we just opened our studio. But then now we can see that our dplyr is now loaded. So everything that is loaded, it has a tick in this specific column.
Oh, yeah, awesome. Thank you.
Of course. So for instance, graphics seems to be a default package. So everything that is kind of default is also ticked. I don't know.
You said
Okay,
to take notes, just do the pound sign, right?
say again.
To take notes, just type pound sign and then add your notes.
A hashtag.
Or
Yeah.
hashtag. Because when I do it,
Hashtag.
nothing happens on my console. It doesn't transfer to the console, whatever I type.
It's because basically that's a good thing, because you don't wanna type, like you don't wanna type your notes to the, you don't wanna type your notes to the console. You just wanna copy and paste everything that is a code to the console.
Okay, thank you.
Okay, guys, I wonder, for those people that have not raised your hands, what is happening that you were unable to load the package? Like, I kind of wanna make sure that I think we have like around, I don't know, 10 people that have not raised your hands to. So I wanna, okay, 22 now. Please do, just so we get, raise your hands if you have loaded if you have installed the package, and if you have loaded the package to your R session. 24. So I think Carlos has done that before too, right? Christopher, Hamad, were you able to load, install and load? Okay. Yes, for some reason I have two logins. Rosetta, have you managed to install and load the package?
I'm logged in twice, I think. I think I disconnected my phone, so I think it's gonna cause less confusions now. Sorry about that.
Okay. I think I'm gonna keep going then. And how do I clean? Can you clean the lower hand? How can you clean this, Silvio?
Yeah, I'll do it.
Okay, thank you. Okay, perfect. So like we learned just now, we use the function called library to load the packages that are already installed. And like I said, like I said before, you could also just take there here in order to, in this specific column here, in package in order to load the libraries. And it's sometimes gonna give you warnings or errors, so you need to be careful. Like you need to read what is being like released to you. So there are a lot of options when it comes to finding help in R. So the quickest way to go to find help for a specific function is to go to this specific place here called help in the bottom right hand corner tab. And then you can use, like I said, the search box here. So this is the search box command to ask for a specific help. Basically, what we could do is also like, I know there is a function called, no, like let's say library. What does library do? So library, as the function library and the function require, they load and attach packages that were added on to your data. So basically we learned about, so normally when you go to this help in R, you get a description, how you use that specific function. And sometimes you even get very detailed information about the package. And also what is sometimes very useful is that this specific help gives you examples on how to use this specific function. So I'm gonna give you like 2 minutes for you to type one name there that you were kind of curious about. Maybe you want to type about dplyr, you want to type about ggplot. So just do that now using the tab help in our RStudio console panel. Michael, you can ask.
I have so the help tab is for using like functions that I already know or packages that I already know. But what if I want to look for an unknown package, or let's say install a package? Can I write this in the search bar and they can give me the function? Can it be in the opposite direction?
So for instance, sometimes actually even help can be useful for that. For instance, let's say, I don't know, tell me something, like tell me.
And install a package from like somewhere.
Because even if you don't know the name of the package, sometimes the help is going to give you like some specific tips related to that name. Let's say plot, I don't know. It's going to give you a lot of different functions that have anything to do with plot, you know. So for instance, I don't know, you would be searching for plotting PCA, then you go there, plotting a principal component analysis. Then you can see that actually you could use the library called ggfortify and then to be able to plot. And let's say we want to do a principal component analysis, right? Then we go back to that plot PCA, but like there are a bunch of different help pages as well that could be, they basically search for the word and not necessarily like the exact name of the function.
Oh yeah, that's cool. Actually, it works like its own Google kind of thing.
Yeah, basically that, and they for sure use their own. They do search in the web page.
Great, thank you.
Of course. Okay, so you guys now learned how to like find out about specific functions or specific things that you would like to be doing. For instance, I don't know, I'm gonna type here single cell RNA, or maybe I'm gonna be, so here they gave me a bunch of things, or single cell, I don't know, single cell this sec2, for instance, you could use this bulk differential expression analysis results with bioconductor single cell or RNA-seq dataset. So for instance, we could use that one in order to run single cell analysis, which is cool. So yeah, it's very powerful. You can type as much as you want there, and it's gonna bring you a lot of different tips or packages and everything. So we are now like reaching around an hour because we have done a little, I think we have already done a bit. I'm gonna go through this specific chunk of text, and then we're going to take a break. So like I said, we could use the help here tab in order to find resources about a specific function that we would like to be applying. But sadly, not every documentation for a specific package is very good, you know. So our next best friend, like Ibrahim said here, is the internet. And to be honest, I'm gonna ask Sion if that's the case for him, but I don't think I've ever spent one day without Googling something. Is it correct, Sion?
That's right. I Google for everything basically.
So don't be ashamed of using the internet to help you out to solve a specific problem, you know, to understand a specific code. Because the more you search for, you also feel like the more you understand that all other people have gone through that struggle, and other people actually have solved their problem. So that's an exciting thing. So as Ibrahim has written in this workshop here in the documentation, he says that there are a bunch of information out there in the internet that we could be using in order to help us out with coding. And one best friend of RStudio is the RStudio cheat sheets. I don't know how to cheat sheets. I don't think I'm pronouncing it correctly. Sorry, American people. But yeah, so you could use those. And basically, if you go back to our workshop materials, you go back to this one, intro to R and data visualization, and there in that specific folder, we'll be seeing the different cheat sheets. And Ibrahim said that he would print this and leave it like next to his desk or in front of the front desk in order to remember what kind of function one could use. So for instance, this one is for understanding about R Markdown. This one is to basically understand the specifics about this package called ggplot2, and which we are going to be using tomorrow in order to plot data. So it's very powerful because it's very organized, and you just need to refresh your mind basically. So don't be afraid of using those. So dplyr is the package that we're going to be using in order to manipulate our different data frames, like filtering out specific columns, you know. So this is another cheat sheet for that. So if you want, you can even download that to your desktop. Okay. But beyond those cheat sheets, we also have other places that you could be searching for a specific help. And it's documented here. Okay, guys, so now it's 10:15. So I'm gonna give you like 15 minutes of break for you to stretch and do like maybe go through these cheat sheets or just relax. And then at 10:30, we're gonna be coming back in order to continue our workshop. I'm gonna pause recording. How do I do this? Forgot. Let's get back to our work here. So you guys learned what our studio is, what R is, what are the different panels here mean, how to get some help, how to install a package, how to load a package. Now what we're going to be doing is how we are going to learn how to import data. So one thing that is very important to learn is about the working directory. I don't know if you guys have done this before in programming language, but whenever you are doing something, you need to specify to your computer or to the terminal here, to the command line, where exactly you are working or where exactly the specific files that you want are going to be located. And so in R, we also need to do that in order to import a specific file, or you need to tell R or the console here that the place where tell a specific the directory of the directory of your file, and basically tell R where the thing is located. So I'm gonna teach you 2 ways of doing that. First, we are gonna use this function called getWD, and basically this means like get working directory. If you command return that function now, you're gonna see that my working directory right now is in users, PM, and part1. And this is good because that is, when we look at this, that is exactly where I want to go, because I want to access these specific files here. Another way to set your directory, if your directory is not it's not showing exactly to the part1 folder, is to do the specific thing here. You go to more, which is this nice little tool here, and then you say set as a working directory. And basically what that is doing is setting your working directory to be the folder where our project is contained, where this is contained. So there is a question in the chat. Yeah, so we go to more, and there you're gonna say set our working directory, set as working directory. And basically that is the same thing as us typing down set WD, and then you type down the whole path to that, the whole path, or with tilt the specific path to that directory. For instance, if we go to my PM here, basically this is where my things are, right? My folders, my files are, and if you see here get info, this is going to show that it's in users PM part1. And you want to set your working directory to that specific thing. So you basically do that as well. Both things work. I think this one is much easier because it does automatically to you. You don't need to worry about where exactly you are. So whenever you want to access a file, you need to tell exactly where in your computer that file is. And another thing that is useful is that, like in the terminal, what you could do as well is to use the function dir, and if we go to if we type that, it's going to actually specify or show to you every single file that you have, or every single different type of thing that you have in your folder. So here we have two different files that are common, a CSV format, and then we have the R project, and we have the part one R script, like we see here. So now that we have everything set, now we want to import data. So in order to work with R, we need to import data from an outside source, in this case, this folder, right, into R. So there are many built-in functions in R that we can use to import data. And for this particular lesson, we'll pick apart some public. So we're going to be picking apart some public health related data. I know we are all tired about with COVID, but we're going to be handling COVID data set. I'm sorry. So we are going to be, like you see here, we are going to be looking at two different COVID data sets. The first one is a table from California County population information that Ibrahim has made in the Excel, and he saved that as a CSV format. Can someone explain what a CSV format is? No one wants to explain. So it's a comma separated file, right? I don't know what the V stands for, but if you like just step, oh no, it does actually, it does look nice. But if you were supposed to just do like open with text editor file here, you'd see that it's all separated by commas. So that's why it's called CSV format. Okay, so CM says that is comma separate values, not so comma separate values. So the first data set is the California County population information that he has made in CSV file, and then the third data set is sourced from the target student community, looking at measles vaccination rate at school across the country. We are going to use these data sets to learn about the functionality of R and ask some basic public health questions through this lesson. So the first data set that we're going to be using is the county data data set, which is this one. So we have already done this. So if we do this, I think you guys can guess that this is going to give me an error because my file is not, my specific part one folder is not in this directory. So don't worry about this. It is going to give you an error. But then now we are going to load our first data set into R, and the basic base R command line for reading a table that is any type of table is this function called read.table command, and then we can read the table into an object using the assignment operator, like assigning operator. So basically, you need to type. So I'm going to type here read dot, and then it's going to give me a bunch of different options, but we want to read table. And then read table, as you can see here, asks for a file, and the file that I want is the county data, right? Like they are, like we were typing there. And then I want to say that this file, as you can see here, let's just first of all try to do this one and see if it works, the first one above, or maybe let's just type it like it was written there, true, and then step is equal to, oops, I put it up uppercase, and then we're gonna say count pop. And then in order to, so we are trying to read a specific object, and we are trying, and when we do this assignment, we are assigning that specific read object to a name, to a specific object called count pop. If you try that, did you guys get an error?
Yeah, yeah. You have to put .csv there.
Yeah, correct. Who said that?
I did.
You're not supposed to.
Oh, sorry.
Because
Oh,
so
what was it intentional?
is that you? I can't see if it's you. Is that you
Yeah.
that I was talking? Yeah. Okay.
Oh, yeah. What was it intentional?
It was for people to realize that
Oh,
basically.
sorry about that.
So we want this data set, this data called county data, right? But when you look at the directory like we did here, we know that county data is not only county data, it's county data.csv. So you need to type down the full name in order for R to understand what specifically the data that you are trying to import. And another thing that now try to type it. Okay. So tell me if you're able to read the table county data. Okay, Maya asks, could you explain what count pop means and how you need to write that comment? So we are gonna learn about count pop in a second and how you need to write that comment. I mean, you basically learn with experience what exactly command you need to learn or need to type in order to do something. So you need to memorize that. But another thing that I wanted you guys to learn is like the specificities of that command, right? So that command is asking, so we can go here and like in our help and say read.table. And then we're gonna see that, okay, read.table reads a file in table format and creates a data frame from it with cases corresponding to lines and variables to fields in the file. So as a default, it has all of these things as default, but it only requires basically for us to type the file, the header, and the separator, how the specific file is separated. So we know from just looking at this in a text file that it does have a header, right? Because it has the column names here. So this is the so-called header. And it is separated by comma. So we can just say, okay, header is equal to true. And I also know that that specific file that I want to read is equals to, is separated by comma. And the count pop, you can actually name it whatever you want. So it could be called whatever. And that would be also acceptable. So what we care about is the function that we are using to read the file, but also what if we are writing a meaningful name to that object. And another thing that I want you guys to pay attention now, remember that I said that global environment is very useful because it makes you understand what is happening once you manipulate your data. And as you can see here, we have this object called data called county pop, which is this one here. And it also gives us more than just the name of the object, but also gives us some other information like the number of observations, I would call like number of rows, and the number of variables that are also called like the number of columns of your data. So if you click it there, you see two things happening. First, you see that R just wrote like a script on its own called VO parentheses county pop, and then you also see that a new window show up in this left corner panel, which is basically the data frame that we just loaded into R. So these are the variables, so 4 variables, 1, 2, 3, 4, and these are the observations, so also up to 58. So if you wanna, instead of pressing there, you wanna actually just type the function VO, can also do that. So let's do this with whatever. And then you do command enter, and that is gonna pop up the whatever data frame. Any questions? Ooh, so many questions. Okay, so so do we want it to be county pop? Yes, because, so Sarah asked, do you want it to be county pop or count pop? County, because actually these are, I didn't know about that, but apparently there are 58 counties in California. So the county Los Angeles, the county San Diego, and so on. So that's why it's county pop. Ricardo Fausto says, county pop is not a command. You could have put anything there, just a place to put your data in the R environment. You could have used type it blah, blah, blah. Yeah, like I said, whatever. Yeah. What then Sarah asked, also, is there a functional difference between single quote and double quote? No, not in R actually. You can correct me if I'm wrong, Sion, but not in R, right?
Yeah,
and another,
unless you are using single quote or double quote inside the string.
Yes, if you're using, like if you did something like this, that would matter to R. But I could use like interdigitally like I did here. And another thing that I want you guys also to remember, that this sign here, so I'm going to make a comment. The sign assignment double quote is the same as using the sign equal, only one equal. So if I want to do, I could also just do blah, blah, like Ricardo who said that, blah, blah. I think it was Ricardo, blah, blah, and then equals, and then read table, blah, blah, blah. Ooh, sorry. And that would also be correct. So I actually sometimes use, I would prefer equal instead of the sign, but you do what you think is best for you. So what does header true mean? So let's try just to see here. I'm just gonna delete this, or I'm gonna leave this so we remember what we were doing. Let's just try to say header equals to false to see what happens. So we are saying that the header, there is no header, right? Let's see what happens to our data. So because we said that there is no header, then R understands that they need to call your column names something, and the default to call for something is starting by V1, V2, V3, V4. So now the name of your columns is not rank, county, population per 10K. it's actually v1, v2, v3, v4. And later you're going to understand that if you want to address to a specific column, then you'd not be addressing to pert and k, you'd be addressing to v4. So, but because you know that you actually have a header, then you can say, yes, I have a header, and that is true. And then let's go back to what happens there. You see how like the bold column names became the actual column names. Okay, did you understand, Emma?
Yes, thank you.
And Emma, we're gonna learn a little bit later about this, but you can use the function called rm, and then you're gonna wait just a second or some seconds. So Raf asked, why does R have multiple functions with same outcomes? So that is another thing, like some people are not satisfied with a specific function, then decide to create their own function. That's why R is powerful, but also very, like, it's scary, right? Because it becomes overwhelming. But basically, a specific functions, like we say here, they are meaningful to specific types of data frame. For instance, the limit here, read the lim is a specific, like, do you see that the default here is separated by backslash t, and that means that it's separated by tabs. So if our data frame was a data frame separated by tabs instead of comma separated, then the most maybe the most useful function to be using would be this read the limit here and not read table. Do you get that, Rolf?
Yeah, thank you.
Yeah, when we have header is equals to false, then no, R actually creates for us, and the way that it creates is creates like v1, v2, v3, v4, v5, like we saw. Okay, you were good at answering. See you, thank you. But it's also good to kind of like go to people's doubts, because I think that it's useful for people to learn. Okay, great. So now we have county pop. Forget about my blah, blah, whatever here. We are gonna learn later how to delete those things. Now we know how to see the data frame. That's one of the powerful things about RStudio, because you can really see what is going on, right? You can really see your data. You could press there in the global environment, sorry. Or you could use the function called view. Now, like we were discussing about this, there are a lot of strategies that can be used to assign a variable object names. Like I said, we could use the sign like assignment or the equals sign in order to address for a specific name. But talking about names, generally it's best practice to assign things with names that are short, but descriptive and without space, because you don't want to mess around with space, you know. And here are some of the example naming conventions. So Ibrahim said that you can name things like this, like he personally likes to name things like first word and then the second word starting with uppercase, like we did for county pop. You can also just use that like without uppercase thing, but that is not as, it's harder to read than this one, right? I think you guys agree with me. You could also use dots in between the names, but I don't know. Yeah, you could also do that. I use many times underline. it's not very recommended that we use the dash sign, because like he says here, the dash could also be used for subtraction. So it becomes very, it can be dangerous when you use the dash, because then R doesn't know what it is about. And another thing is that you cannot use numbers in the beginning of the string for a specific name. Like you're gonna see that R is gonna complain in a second, you see? But if you use that in the end of the string, it doesn't complain. Do you see that? It's magic. Okay, so let's load the other data set. And I want you guys to do that on your own. So just so you can you remember how to do that and what specifically you need to remember in order to load a specific data set. I'm gonna give you like 2 minutes, and I want you guys to answer, to tell me what exactly I need to put here. But also remember that you could also just go to your folder and figure out like how the folder looks like. But actually, I think it's better if we do the like a text file. So type with me. So do you think it has, do you think I should put true or false here? True, okay, then we type true, and true is uppercase. It cannot be a lowercase. Or you could also just do T. T and true is the same thing. F and like uppercase. F and false is the same thing as well. So true or T. And which separated do we have for that specific table? So we also see that it's comma separated, right? So what should we put here? Now we run. What do you think is going to happen? We are going to have another global variable called county vax data, CA. And this one is much bigger, right? Because we have 25,810 observations, 21 variables, which then, if you want, we can have a look at that. So we have 21 variables, which are also 21 column names. So you have date, county, FIPS, population, doses, administrated, new doses, administrated, Pfizer doses, new Pfizer doses, Moderna doses, new Moderna. So Johnson Johnson doses, partially vaccinated, new partially vaccinated. So it's all about different things that related to doses that has happened in the different counties. Cool. Has everybody gotten to this point? Do you guys have the county vax data CA object in your global environment? Say, give me a reaction. Yeah. So Maya asks me, could you explain how you got it in the global environment one more time? Yeah, all good questions. So the first question is, so how do you get that in the global environment? Basically, whenever you enter this and actually goes through, then whatever object that you write and goes through, it's going to go to your global environment. So that's how we get there. And like I said, there are different functions that could be used to read a file. We first used read CSV. We first used read table, but like we see here in our help here, read table could also be done by read CSV, like other functions like read table could also do the job. I think one of the ideas of read table here, read CSV, sorry, is that by default, it defaults that the separator is a comma separator. So we basically, if we take this out, let's just try to make a test here. It's not going to complain because the default of the separator is the comma. So you see here that by default, it has this. So if you are sure that your data is CSV, it's a CSV file, then you can just use read CSV instead of read table. Do you get it?
I do, yeah, that makes sense. Thank you.
And remember to keep like, saving your stuff, you know, so command plus S or control plus S in order to save this stuff, written to your .r file and save again. Okay, so another way, one thing that is also powerful is that we could actually import data from an online directory. So in this case, we will be using a data set from this data set collected by Tidy Tuesday community. And if you're looking to get some extra practice with R, this is a very nice source because they basically, let's go there. It's funny, it's not writing. If we go there, they actually, every Tuesday, they upload a new data set. So today is Tuesday, so 17 hours ago, they have uploaded a new data set. And basically there, you see about the examples. They also have a package called Tidy Tuesday R, and then you can actually load the data set specifically for that day, in our case today, which is super cool, right? You can also say, I don't want to say by date, but I want to say the 4th week of 2022, and then we're gonna get the data set. So, but because we are going to be using like this previous data set from this disease or from vaccine rate, we're going to be using this, how do I pronounce that? Measles? Can someone correct me?
Measles.
Measles, thank you. So, because we are going to be using this specific data set from this specific date, which was the 25th of 2020, so February of 2020, then we are just gonna, we take the whole like specific working directory, and now I'm gonna try here because I don't remember if it has header or not, but I'm gonna try and then I'm gonna say that it doesn't have a header. So I'm gonna say false, and let's see what happens because coding is also like working, trying and failing, you know, and I want you guys to understand that it's the case. Don't be frustrated about that. So you see, so this gives me a very good hint. First of all, what is the first hint that it gives me? Does it have a header or not? Yes. So, and what is the second hint? Yes, you guys are doing great. So what do? So I go and say true or T, uppercase T, and then comma. And then now, done. And then there are two ways to view the data frame. What is the function that I could use to type to view the data frame? Okay, so leader, yeah. So okay, so this is the way that we could view the data frame. Oops, sorry, I couldn't copy. Copy and paste. Okay, this is the way that we view the data frame. So lead or Levi, he asks, or yeah, I think it's a he. I don't know. How did we know it had a header and was comma separated again? So I'm gonna do this again. So we know because, whoa, now it's a mess. Okay, I don't know what I did. It's because I did before, how was that before? There was no separated one.
It was a question mark.
Was it?
Yeah.
Yeah, then that makes sense. Okay. Okay, so Lindur. So here we know that it has a header because we can see here, first of all, that this first row here is just names, right? So you basically know that because it's only names, it must be a header. It couldn't be something different, right? And then, so the first column is the index. So it's just 1, 2, 3. So just indexing the rows. And then you can see that each row is separated by comma and not by something else. If it was a tab separated data frame, then we would have this backward slash and then the T by each column. Or actually, we would have spaces, right, Celia? We would have spaces like tabs. Actually, I don't know. Now I'm confused. I don't know. But you wouldn't have comma. So that's how you know which separator we get. Yeah, it was very quick, right? So yeah. Okay, so let's just go. It has a header and it is comma separated. Basically, when we have this question mark, we are telling R to separate our data frame by question marks. But because we have no question marks, then it doesn't separate it, put everything into a column. That's another thing that we are getting out of this the way we typed. Cool. So I've been talking and saying stuff out loud like data frames, functions, objects, and vectors, and I don't expect you guys to understand and to know every single of these names, but I want to introduce to you like the different data structures that are talked about in R. So whenever we talk about a data structure, you have a background idea of what we are talking about, right? So R works most efficiently with data in the form of vectors. And vectors, the way you can think about vectors is like, it's a list of information that fall into a particular class, and then multiple vectors of the same length are then joined together to create a data frame. So when we look at our measles vaccine rate here, we can think that these are different vectors that are put together to create a data frame. So whenever you have this type of structure that contains observations and variables, you have actually, in this format here, you actually have a data frame. So this data frame might look similar to a table you would see in Excel, like we saw here, right? This is a data frame. And it's similar to what you see here, right? Okay, so, and a data frame can have multiple classes of data, but a data matrix can also look like a data frame. But the exception is that a data matrix are limited to one only class of data, and these are numbers. So I recognize several classes of data, and several classes of data can be packed into vectors, and that constitutes the data frames. So I'm going to talk about the different classes of data that we have. So we first could have characters, which are basically strings of alphanumeric characters that have quotation marks around them. So as an example, example of a character would be COVID. Sorry, guys. And that would be in quotation marks in your data frame. I think it's single quotation mark, right? You see you? Later, you're gonna understand. Integers and numerics, which are different classifications, could also be another. So what is an integer? Can someone type something? So 1, 2, 3, and numerics, right? Could also be, I actually don't know exactly the difference between numerics, but I guess it extends to floats. Is that true, Sion?
Yeah, if you just type 1, 2, 3, I think it's basically integers. Let me
And
check.
then, yeah, so like it says here.
Oh yeah,
decimal
basically
numbers and
numeric.
scientific notation. So for instance, here, this would also be a numeric. So
numbers you type in are basically numerics, and integers are used for mainly indexes.
I see.
Yeah.
And these would be a numeric. These would be a numeric. These would be a numeric. And then logical. So whatever logical is like true or false, right? This could also be one class of data in R, vectors in R. And we can also categorize vectors as factors, which can be a mixture of classes listed, a mixture of the classes listed above. I don't think you're going to be working with factors, but understand that it could also be a factor. So depending on the number of columns or rows that you have, you might want to use one or more strategies to find out what kind of classes you have in your data set. So the quickest way to view a data set is to use this function called head. And then you actually want to see what it is in our counterpop. And basically what it's going to do to us is going to print in the console just the 5 first rows of our data frame. So try to type this head county pop. And you can see here that rank is a numeric column, right? County is a character, like it has like strings. So it's a character column. Population, it is a numeric, but we're gonna see that it's actually written as a string. And then the per 10K, it's a numeric column. So if you want to see the tail of your data frame, you can just type the function called tail, and then you go to and find and look at the tail of your data frame. So as you can see, our data frame is sorted by the first column, which is the rank column. So it ranks from 1 to 58. And you can also see that the way that it was ranked was based on the population. Can you see this here? So the first one is with the highest population size, largest population size, and this is the smallest. Alpine is the smallest population size. One way to look at the classes of your data frame is by using the function class and looking and just typing the whole data frame. Let's see what it's going to get from this. So the whole data frame, the whole object class box data CA is called a data frame. And then if you wanna understand the specific class within a specific column in your data frame, we can use the $sign. So the $sign is very powerful with data frames because it allows us to select from our data frame a specific column, and in that way we can okay, I want to see it pick there, like say, okay, press select county, and then if we run this, it's going to show all the different names within that vector county. Like I said, data frame is a compilation of vectors, and in that vector is actually of class character because it is a string. What did I say wrong, Sion? You can correct me.
Yeah, there is for string, yeah.
So this is a vector that contains the strings within that vector, and we know that it is a string because it is it's not a number, right? And it is quoted around the name, around that string. Do you guys understand that? So what other, like, let's try to analyze another column. Let's say Pfizer doses. So do you see here that it has this name called num? So this is a vector, right, within that data frame. And it's classified as a numeric vector. So that it contains the number of doses of Pfizer doses for each of those counties. Another way to do this is by looking at just, so here when so when we do this is str here, we are trying to look at the entire vector and the entire that entire column with the data frame. But if I only want to look at the class that the data frame corresponds to, then I can just use the function class, and they specify the column that I wanna know what class is about, right? So I want you guys to go to both the measles vaccine rate and the county vax data CA. And I want you guys to explore different columns of the two different data frames for the next 2 minutes. And I'm gonna be doing that too. So here, for instance, I'm choosing city. I think I can presume that the class is a correct character, right? Because city is a string, it's a name, so it must be character, right? Yeah. So let's think about other. Let's say, whenever you want R to help you out, R Studio to help you out with like giving you options here, you can press the tab in order to get these things to show up to you. So the tab sign. So I guess state is also going to be a character thing. Let's try to find a numeric one. I guess index must be numeric, right? So Ricardo says that yeah. No, so yeah, so Ricardo is asking here, when we go to the county pop. So yes, so that's what we're gonna, for some reason, this was written as a string and not as a numeric. So basically the way they wrote this was something like instead of being numeric without those commas, it understand as a string, so it understand as if it was something, an object like this. That's why it's seen as a character and not a numeric. So for instance, it seems like that, let's see what class this county is, class. Let's try to transform this column here that has a character, that is a column with character by in numeric. Let's see what happens. So the reason why it gives us this NAs is because R doesn't allow us to transform an object that is a character to numeric, but the other way around is possible actually. So yeah, so one way to replace this, transform this, I'm gonna explain that in a second. So, but let's try to do then if we look at the county pop here, now you lost all your data. Don't worry, we can go back to where we were. That's why whenever you're trying something out, you should like try to always make a second copy so you don't lose your data. So let's just try to make it as factor. It actually allows you to transform the county as factor, but also gives you an ace, which is funny because it doesn't give you any complaint. So let's go back to there. Well, it's because I'm trying to load something that is here. Sorry. Yeah. It actually allows you to transform this character one into a factor. It doesn't change. Let's see. Let's check if it worked. Like, let's find the class. So yeah, basically, what you're telling. So Emma asks, what does the s dot function do? Basically, it's transforming your function that you know is numeric into another type of class. So as character, as factor, as numeric, you know. So if you want to transform, so let's just find out what class county pop per 10K. So what class county pop? And then you find per 10K here. What class is that? It's numeric. Let's just make this stupid thing that is transforming a numeric class into a character one, because at the end of the day, we want numerics to be numerics and strings to be strings, you know. But let's try to do that. So here, what we are doing, which is dangerous, because we are overriding the column county pop per 10K, and then we are trying to transform something that is numeric. It's not gonna work. I know it is gonna work the other way around, but it doesn't work. As character, and then you do the 10K again, and you see here that it didn't change much, but it changed the way we see the object, right? Now, do you see here that we have the number between quotes, which is not what we want. We want the number to be a number. But sometimes when you have a specific column that is in the wrong, is specified the wrong way, for instance, a numeric being a string or a character, then you would want to change using the function s dot blah blah blah. Do you guys get it? So let's just see if it worked. So county pop per 10K. Oops, county pop. So it became a character one. So I want you guys to check the class of the county pop county data to check to see if it worked. So transforming that. So here that would be, we were transforming the county pop county into a factor, and now we can see if that worked. It is a factor. Yeah, so basically to change it back, we can do just the other way around, right? So we can transform this as a character. And then we can check again to see if it works. It worked. And I want to do that again for the per 10K because that is going to be dangerous to us. So we actually want county pop to be county pop column per 10K to be numeric, not a character. And then we can check if it worked. Numeric, good. Raise your hand if you have, how do we reverse DNAs introduced by yeah, so that is one thing that we can't reverse, Christopher. We can only do that by reading the table again, because you can't reverse NA because you just lost that information by doing the mistake of transforming, what was that? Transforming a character in a numeric, right? That is how we got to a NA. So what you can do is like go back to the county data. The first time we called county pop, and then or rerun that, or copy and paste and run that again there, just so we all are in the same place. Raise your hand if you manage to change classes and change it back. Cool. So now I'm gonna go to, now another function that is useful for you is to, let me just find out. Okay, we are in the very end of our course. I'm gonna give you like a 5 minutes break just so you guys don't go crazy. So we are coming back 11:37, and we are going to go to the end of this session, which is trying to work with dplyr and to clean up our data. So you can go do, you can also stay if you want.
Would it be possible to quickly go through the changing classes again?
Yeah. So what exactly you didn't understand?
Well, I guess I couldn't get mine to change. I also got the NA issue. So maybe the last thing where you showed how to change it successfully.
We got the NA part because we tried to transform a character in numeric, and R understand that as a problem, so that's why it gives us NA. So one way to fix that is just to read the table that you looked at, and I think the one that you looked at into is the county pop one, and read it again, and then you recover all the information for that specific data frame.
Yeah, I got that. It was just this last part that you did where you changed it from numeric to character and then back to numeric.
So basically, so here I do, so here, for instance, we do, here we transform this numeric to character. So now it's a character, and it is a character. And then, but we know that the per 10K is a numeric column, right? So then you can just take that one and transform that. Maybe if I put it here, it's less disorganized. So then you just take the county pop column and then say, I want to transform it back to numeric. So you just type as numeric, the county pop, specifically that column, and then becomes a column again, a numeric again. So from character to numeric, back to numeric. Did you understand?
Yeah, I was just working through it. So I got it to change to character, and now I'm going back to numeric.
Okay. But did you understand why we got the NAs?
No, not really.
So we got the NAs because we are trying to transform a character in numeric. So the other way around we can, but like we can transform a numeric in a character, but we cannot transform a character in numeric.
Okay, so if I do this, so you're saying we can transform a numeric into a character, which I did, but you can't transform a numeric into a character?
No, but we cannot
sorry.
transform a character to numeric.
But isn't that what we're doing when we switch back?
That is actually true.
Yeah, I wasn't sure why it happened before.
So the reason why we can.
Yeah, so that worked. I don't know why the first time when we were trying it didn't work.
The reason why we can is because by default is a character. So we know that this is a character, right? And we are trying to transform something that is a string with names into a number, and that is impossible. Do you know what I mean? Like if I want to transform an algorithm, like, do you know what I mean? But
yeah,
you can.
So because I tried to do it.
You can code numbers, right? You can code numbers. Like this is what is going to happen. So we have numbers here as numbers, but you can code them. You know what I mean? You can do that, but you cannot transform.
So if it's a string, it won't. You can't change it because I try to change it because I try to change the populations instead of county pop county. I did county pop population because I figured it's numbers. And it would work, but that didn't work either because I guess it's a string.
Yeah, like we talked about that, and we are going to fix that tomorrow, how to fix that. But like if you look at this, if you look at the, can you see that they are strings and not numeric actually.
Yeah.
And we're going to look at how to solve that tomorrow.
Got it.
Okay,
thank you.
Of course. And then another thing that is useful is to know, like you have your data frame, and to know the names that are your column names. You can just use the function called call names, and then you can say, I want to know what are the column names for my data frame, fax data CA. Enter that, and it's going to describe all the column names for that data frame. That's why I call these variables columns and the observations role names, because they are also called roles, right? So if you want to know the role names for county pop, you can just type the function called role names, county pop, And it's actually gonna give us the index names for that county pop data frame. If you go to your data frame here, these by default sometimes does write the column names as the indexing of that row. But sometimes you could also change that if needed and if you want to. Okay. So there are a wide variety of built-in functions for summarizing data, and below there is a list of few of the more useful comments that we could be using in order to summarize our data. So, for instance, we can calculate the mean or the median of a given data frame that is numeric. We can also understand the standard deviation of that specific vector of numbers, the minimum and the maximum, the quantiles for that specific data frame. We can also know about position, what is the first number, what is the last, which number is a specific, which is located a specific number. We can also count the numbers and summarize the data, and we're going to learn a bit later how to summarize the data. So now I wanted you guys to explore, for instance, the mean function. So like I said, we have county pop here, for instance, and we want to understand the mean per 10K population size in the California county. So to do that, you could just say here, mean, and I want to look at county pop, and I want to look at per 10K. Run this and tell me in the chat what the mean is. Okay, so Emma says that 67.73. Yeah, and what about the median? Because sometimes your distribution is skewed, so it's better to take the mean skewed, like with a long tail. So it's better to take the median than the mean. So sometimes we would use the median. So what is the median? Yeah, Daniel says 18. Just to give you like a slightly notion about how powerful R is in terms of plotting, I wanted you guys to make a histogram of those of this specific vector county pop per 10K. I know I'm just doing that because I wanted you guys to see this. We are going to be talking about visualization tomorrow, but there is this built-in function called hist that you can very easily use to create a histogram. So you type hist, and then you type the vector, then like the data frame and specific column that you're interested in order to make a histogram. And do you see here that is actually, this one is actually LA, Los Angeles, and everything else runs around here. So if we look at our data frame there, you see that LA is very skewed towards like the end, right? So the distribution has a very long tail. So it does kind of make sense to take the median instead of the mean. Okay, so as for our last 15 minutes, I would like you guys to pay attention because this part is very important and we are going to be using that tomorrow as well. So the easiest way to start working with data, with cleaning the data frames is with this package, these two packages called dplyr and tidyr package. So they offer a variety of commands that can be used to filter and clean the data. So in order to make your data sets more manageable to work with or to visualize. So as you remember, we loaded tidyr and dplyr before in the very beginning of our course. And today we are going to be learning about two different functions with with type R. So there is the select command or function that can be used to select specific columns from any table that you want. So, and what we are doing here specifically, we are creating a new object called county pop filter, but you could call it anything, like you could call it count top pop subset, and then you assign that and you say from my county pop data frame. So the first thing that you're going to be addressing is the data frame, and then the next other variables that you're going to be addressing in are the names of the columns that you're interested in to keep into your data frame. So I want to keep county. Oops. Let's say I wrote this way, pair 10K. Let's see what happens. So, like I said, sometimes the warning message or the error messages are useful because they say there is no county, because actually it's not with lower cases, but with uppercase county. So then you say county subset. Here you can see that the subset or the filtered one doesn't matter. You only have those two columns because these are the columns that you decided to select. What if I want instead, not only that, but also, but actually I just want a population and county. Then I would say population instead of 10K. Oops. I seriously don't mean to type it wrongly. So then we go there in the subset. And you see also that is very informative to be looking at our global environment, because here we can see that now we only have 2 variables or 2 columns instead of 4 in our original data set. And so, yeah, now we have 2 variables. And another powerful function or command is called the filter command. And the filter actually select a specific roles of your data set. So basically, the filter here is saying filter in our data frame called MMR vaccine rate. In the column state, filter everything that is equals to California. So let's just go to our vaccine rate, and let's go to state. And let's see now, I don't want a California, I actually love Arizona, so I'm gonna look at data from Arizona instead. So instead, what you could do, vaccine Arizona. No, Arizona is easy, right? Filter MMR vaccine rate. So this is the data frame. And then you say that the column is state, oops, is equals to Arizona. Okay, so, and then let's see if this works. So see that I actually decided to type it lowercase because I forgot that it was uppercase. I don't know, right? See what happens if you type lowercase. So basically, it's not finding that string that is Arizona lowercase a in our data frame, because what it basically tries to do, this command filter, is it tries to go through every single row for that specific column state and tries to select filter everything that it is equals to Arizona, or basically Arizona. But so Emma is asking here, why is there a double sign like the state is equals to California? So this is an important thing to remember, that whenever you want to say that something is equals to, it needs to be double sign equal. Because do you remember that I said that this sign here could be used as synonymous to this one? So that's why you need to do double equal in order to specify that you want something to be exactly the same as that specific string. So here to correct me, I need to put it like Arizona with uppercase. And then you're gonna see that actually we got like 1451 observations for the Arizona state. Like I want you guys to try now a different county. Let's say, I don't know. Let's say New York. Is there a New York? I don't know if this is gonna. Yeah, I want you guys to try New York because I like New York. And tell me how many observations that are left when you filter for New York State. So Michael is asking, can we combine the select and filter? Yes, tomorrow you're gonna see how powerful it is, dplyr, especially with this sign here. I'm gonna show you. To combine different filtering steps into your analysis. Oops, I didn't send to everyone. So this sign here with the no, the other. Oh God, this one. With this sign here, you can combine different filtering steps. So select and filter function. So how many rows are there, observations are there for the New York MMR vaccine rate? Okay, let's try that. So do you see here, I'm lazy, I'm just copy and pasting. And do you see that you actually need to really write, like you need to put the space, because if you don't, you're gonna get it wrong. And Carlos was right. Okay, so the last thing is that we're gonna be learning, the last function that we're gonna be learning today is this ls function. But this is dangerous, don't do that now, because this would clear all the things that we have done so far in our global environment. So you'd clean all of this. So if you press this one, it's the same thing as typing this function. Instead, one thing that you could, sorry. If you press this one, you would clean everything. So you'd remove everything from your global environment. If you press ls, you would just describe all the objects that we have created in this R session. And these are listed here, right? And then if you want to remove objects that are not necessarily anymore for your understanding for next for tomorrow, like this stupid object called blah blah, then you can type the name of the object and it's going to be removed. Do you see? Also maybe remove whatever. And yeah, and then that's it. So this is a test to what you have learned so far, and this you guys can basically do after this we are doing what we are doing now, and tomorrow we can go back to this part here. But tomorrow we are gonna really learn how to deal with different data modeling or data frames like manipulation, and also learn how to plot which is quite exciting. So I'm sorry if it was a lot today, but I hope you guys have learned something. And let me know. You can always email me or Siyun to answer your questions. And like, just take a deep breath, a brief breath, and like later on today, if you want, go through all these different things to kind of refresh your mind, because it's easier to do when I'm typing with you, but it's harder when you're on your own. So for tomorrow, there is nothing that you actually need really to do. We are just going to be using the same R script. You can do this. You can do this test what you learned, and then you can read the recommended reading. And then after all these specific tests here, we are going to start day 2, which is data modeling with dplyr. Okay, I'm going to stay here for the last 5 minutes, and if you have any questions, I can help you out still for the next 5 minutes. But feel free to leave if you feel like.
Thank you.
Thank you, Emma. Ah, that's good, Robert. Good to know. I think it's easier when you understand what is going on, for sure. It gets you to memorize better.
Yeah, definitely. Thank you so much.
Of course. Maybe can you say soon just for a second, just so we can debrief?
Maria, I have a quick question.
Mm-hmm.
Tomorrow morning, I have a biochem class midterm from 9 a.m. to 10:30, I guess. Is it possible to get the recording from the workshop so I can maybe watch it later tomorrow?
Yeah, I don't know if you're going to be able to get it tomorrow, but I think we are going to release it around on Thursday, but I can ask Eloy to see if we can get tomorrow to you.
Okay, can I still attend Thursday workshop and then maybe understand fully?
Yeah, I think so. And I mean, even if you do that at home tomorrow, or maybe start doing that, you said it from 9:30 to 10 or something?